everyone. Okay, today I would like to present on a wastewater treatment chlorination method. Before I further up my presentation, I would like to introduce myself first. My name is YOGESSVARAN, son of VEKNESVARAN. My matrix ID is 1719. And the three other members in my group is NANTHINIE, THANGARAJOO, 17354, AZIDI SYUKRI bin Abdullah and 17288, Ariff Danial bin Abdullah 17525. So before I continue my presentation, I would like to thank my lecturers, Puan Taslima and Professor Munir Zaman for assisting us all the while to complete this course successfully. Okay, today I would like to present on wastewater treatment using chlorination method. So I will be making you all clear what is wastewater treatment about and why we are using chlorination method. Okay, industrial wastewater treatment is a process or mechanism which covers to treat water which is being polluted or making it impure by other anthropogenic industries or other commercial industries which is doing commercial activities such as chemical industries, logging industries. They are like polluting the environment by discharging the chemicals to river water and then making the water impure. So by this we know what's the importance of water. Water is a major source of supply for every human being, also living things. So we need to preserve the cleanliness of water to be used by all of them without any harm. So in this context, we would like to introduce RTD method to further explain what is wastewater treatment all about. RTD is in brief, in abbreviation, RTD is residence time distribution. What do you mean by residence time distribution? Residence time distribution is a amount of time a chemical fluid spent in a reactor to be reacted and produced away from the reactor. So amount of time it is inside the reactor. So in RTD method we use two types of input. The way of we giving input inside the RTD. One is step input and another one is pulse input. The difference between step input and pulse input is the step input, the change is sustained for a longer time of period, but pulse input, it is only injected in a short period of time and it is also injected in a short, very small quantity. Obviously, step input is more expensive than pulse input. That's why most of the small industries, they prefer pulse input to be used, although its efficiency is way much lesser than step input. On customer requirement. What is customer requirement? Customer is an individual who are involved in purchasing goods or service from suppliers. So we go further. Okay, customers divided into, actually I divide customers into 5 types of customers. Discount customers, impulsive customers, need-based customers, long-lasting customers. Yeah, 4 types of customers. So what do you mean by impulsive customers? Impulsive customers are customers who are not intended actually to buy goods. They are just coming into the industry or factory. They are just looking into our goods and hands-on. Straight away they're interested, they buy. Discount customers are customers who are partners of us or who are very much related to us. They know how much discount we will be giving us on several goods. And long-term, these customers they are attached to us long-term, for the long term. So they'll never go to other industries to buy goods. So in this customer requirement, there's 3 aspects I would like to touch. Type of customers, which I already explained just now. Choice of customers, market scenarios, and challenges faced in the market. Okay, customers' demand today is very high. Okay, what are the customers' demands today? Quality, reliability, and also cost analysis. Quality, we need to give a better quality, the best quality than other industries. We are competing with other industries actually. So they acquire a better quality from us. Wastewater reclamation and reuse system can contain both design and operational requirement. These are the requirements in our wastewater industry in operational terms, necessary to ensure the reliability of the treatment. Reliability features such as alarm systems in industry, standby power supplies, and also treatment process lubrications. From public health standpoint, provisions of adequate, reliable disinfections are most essential features of advanced wastewater treatment process. Disinfection is required to several reliability features must be incorporated into the system to ensure uninterpreted chlorine free. So, secondly, market scenarios. In global market trend, our industry is achieving 8.5% of compound annual growth rate. Compound annual growth rate is a statistical data to measure the trends in our industry in overall market. So, wastewater technologies are used to remove and destroy, as you all know, bacteria and also algae which are being accumulated in the wastewater. We are treating the wastewater back to be clean and supply it back to customers who are needing. The global treatment product market in 2014-2018, they predicted.
Okay, I will continue the flow of the presentation for today. So my name is Ariff Danial bin Abdullah, 17525. So just now, supposedly you already know about the customer requirement for our industry, which is the wastewater treatment by chlorination method by my friend YOGESSVARAN just now. So I will continue with the list of equipment which is we need to use in order for us to achieve the wastewater treatment. So first of all, our industry has the tank, one tank, two valve, one pump, one flow meter, one rotameter, one pack column, one collector, one missing chamber, one blower, and one reactor. So basically, the function of the tank is to store the wastewater before entering our main equipment. So the valve is just to control the pipeline, which is to on or open or close it to control the flow of the wastewater. The pump used is to move the water to suck the wastewater from the tank into the system. The flow meter used is to measure the linear, non-linear mass or volumetric flow rate of the wastewater. The rotameter used to measure the flow rate of chlorine gas. Chlorine gas is entering from the downward. Then the pack column function is to provide intimate contacting of the upper flowing chlorine gas and the downward flowing wastewater. The collector used to store the wastewater after the wastewater got contact with the chlorine gas before recycled back into the tank. The mixing chamber is to ensure the proper mixing level of the chlorine gas and the air. While the blower is to provide a large flow of air and chlorine gas into the process. And last but not least is the reactor, which is used to react some material in it. So next I will present you about the unit description. So specific unit operations are conducted specific kind of unit. In every industry there will be many unit of process in their industry. So for our selection, which is the wastewater by chlorination method, we have 3 unit of operation, which is the first one is the reaction process, the second one is the mixing process, and the third one is the separation process. Okay. So our first unit of operation process is the reaction process. So where is the unit operation process? It happens in the reactor, which is in the reactor we use the packed bed reactor, essentially a plug flow reactor packed with catalyst bed. So the reacting fluid will flow through the tube at a rapid pace and it will react there. So in our industry, the component which is react in the reactor is the sodium chloride and the manganese dioxide. So why we need to react this? This is because obviously we need the chlorine gas in this chlorination method. So in order to produce the chlorine gas, we need to react these two components. So the reactor, packed bed reactor is easy to construct, but work better when reactant or products are dilute. So our second unique process is the mixing process. Mixing process happen in the mixing chamber, which is here. Yeah. Why we need the mixing chamber? This is because in the mixing chamber we are mixing the air with the chlorine gas produced from the reactor. So why we need to mixing this? Because actually chlorine gas is a heavy gas, so it will not easily transport by itself. So we need the air just to transport the chlorine gas, to push the chlorine gas, because it's a very heavy gas here. So the third one is the important process, which is the separation process. So it occurs on the pack column. So this is the very important part in our industry, which is the pack back column. The function of the pack back column is just to purify the wastewater, which is to absorb the contaminant in the wastewater. So the absorption will take place in this column, which is it will separate between the wastewater and the contaminant. In the pack column, we have some materials there, which it will increase the time contact and also the surface area of the outward and the downward material. So it will increase the contact time and also the surface area of the contact time. So when wastewater with the contaminant flow from the upward into the material, the contaminant will be bind to the material, and at the same time the chlorine gas will be released from the bottom. It will kill the bacteria and also it will colorize and give the original color back of the water. So basically, the product of the wastewater, we do not use it to drink or use it for cooking. We just want to make it better for the disposal system, so that we can save the river and the stream. Okay, so that's all about my part. I will give it to my friend Nandini for more going into the process of this system. Thank you.
My name is Nandini Thangarajoo with ID number 17354. So previously, Ariff, Danial have presented in equipment list and unit description. Now I'm going to present on the process description and also the process flow diagram. Okay, I would like to ask, why do we treat the wastewater? It's just a matter of for our environment and for our own health. In wastewater, the environment and the human health is negatively impacted if you don't treat them. So this impact can include the harm of the fish, wildlife pollution, oxygen depletion, and beach closures. So the major aim of wastewater treatment is to remove as much as the suspended solid as possible before the remaining water, which is called the effluent, is discharged back to the environment, like to the river and so on. So as solid material decay, it uses up oxygen, which is needed by the plants and animals living in the water. Okay, process description. In our group, we have chosen experiment 3, which is the packed bag reactor with wastewater industry. So we want to relate both of them. So it is found that packed bag reactors or columns, they are used in wastewater treatment from textile industry by chlorination method. Okay, from this residence time distribution in packed bag has been designed for students experiment on residence time distribution in a tubular character. And the residence time distributor, which is RTD, of a reactor is a characteristic of the mixing that occurs in a chemical reactor. The RTD is determined experimentally by injection an inert chemical molecule or actor, which is called a tracer, into the reactor at some time, and then the measuring of the tracer concentration in the effluent stream as a function of time. Okay, the two most used methods of injection are pulse input and step input. So in past input, the amount of pressure suddenly injected in one shot into the feed stream, entering the reactor in a short time as possible. Whereas for step input, the output concentration from a vessel is related to the input function by the convolution integral. The imperfect pulse of injection is also known as the step input technology, aimed at achieving color removal and the reduction of TDS, BOD and COD. What is TDS, BOD and COD? TDS is the total deposited solid, while BOD is the biological oxygen demand and COD is the chemical oxygen demand. So the operation and performance of the wastewater treatment facility require close monitoring of the parameters that I told is pH, of course you know the pH value, suspended solid, the TDS, COD and fluid chlorine color temperature at this point of the facility as indicated in the process flow diagram. So this is the process flow diagram that has been explained by Ariff, Danial, each type of them and the function of them. So my part is I'm going to explain the pack column. Right. So a pack column is a pressure vessel that has a pack section. The column can be filled with random damped packing and the structured packing section which are arranged or stacked inside the column. Okay. In the column, the liquid tends to wet the surface of the packing and the vapor pass across the wetted surface. And the packed bag reactors is also used in the chemical reaction. These reactors are tubular and are filled with solid catalyst particles and most often used to catalyze the gas reaction. The chemical reaction that took place is on the surface of the catalyst. The advantage of using the packed bag reactor is the higher conversion per weight of catalyst than other catalytic reactors. The conversion is based on the amount of solid catalyst rather than the volume of the reactor. So the chlorination of wastewater achieves the following efficiently. So the benefit is elimination of colors and odors, destruction of cyanides and phenols, oxidation of metal ions, BOD and COD reduction, control of fogs and flies, adding of scum and grease removal and the disinfection. Okay, this is the experiment setup. This a part of what we show in PFD. Just we did experimentally on the PFD that we have shown previously. Alright, in this experiment, a pack column is used for the purpose of decolorization of wastewater from textile industry with using of chlorine gas and to determine the physical parameters which is TDS, TSS, pH and COD. A step experiment is used to perform in this experiment. In the experiment setup. So because it's easier to perform than a pulse experiment. And it tends to smooth over some of the details that the pulse response could show. It is easy to numerically integrate an experimental pulse response to obtain a very high quality estimate of the step response. But the reverse is the case because any noise in the concentration measurement will be amplified by numeric differentiation. Okay, based on the experiment, in the experiment setup, it is observed that the flow of wastewater and the chlorine gas is counter current. So the RTD, because of its counter current, the RTD for the counter current is longer than co-current. This is because the counter current, the air that comes from water, which is the gas, the chlorine gas, has been supported for fluid that comes from the top and maintained at the place. Hence, it increases the RTD. Thus, the reaction of the decolorization that happening in pack column also higher. Okay, from the result, we can observe that the value of TDS, TSS, COD is reduced. Furthermore, the pH value were in the range of 8 to 9. The color of wastewater become lighter as you can observe in the picture. So this is the before treatment of wastewater. And this is the after treatment. So we can see the pack column is helping in the decolorization of the wastewater. And thank you, that's all from me. Now I would like to proceed, give the floor to AZIDI SYUKRI.
Alright, my name is AZIDI SYUKRI bin Abdul GHANI, and for the project, I will continue for the safety and economic analysis. So before this, I think you all understand about the process description and also the PFD of the treatment, wastewater treatment. So for safety and economic analysis. So first for the safety analysis, let us look for the wastewater treatment, what can be produced by the wastewater treatment. So first is wastewater treatment may generate aerosols containing microbiological and chemical constituents. Second is volatile organics in wastewater may be vaporized or air stripped during treatment. So this is dangerous for the workers of the industry. Third is many of the compounds are carcinogens and mutagens. So workers may be at an increased risk of cancer or adverse birth outcomes. So next is industrial workers may be exposed to chemicals or organisms by two different ways. Which is first is direct contact with wastewater, which is the skin contact, and second is inhalation of gases, particles, aerosols, vapors or droplets. So according to the MSDS Material Safety Data Sheet, for this hazard happen, we have to follow the flow of the MSDS, which is for the skin contact with wastewater. First step is we have to wash affected area with soap and water, and second is seek immediate medical attention if irritation occurs. And for the inhalation of gases, particles, first if these things happen, remove the victim to fresh air, and then give artificial respiration only if breathing has stopped. And last is seek medical attention immediately. So this is for the safety analysis in the industry. The second is for the economic analysis. So in general, wastewater is an economic good in a country like India, but maybe not be one in Australia. So with emerging technologies, the scarcity of fresh water and the changing perception, wastewater may be imaged as a valuable resources. And next is running cost of wastewater industry includes is water discharge fee, electricity costs, chemical costs, transportation and disposal, and lastly is maintenance and replacement costs. So basically this is the major cost of the industry. So from the research that we have done, the percentage of each of the running costs, water discharge fee we got 18%, electricity cost 27%, chemical cost that we use is 50%, and for the transportation and disposal it is 22%, and lastly for the maintenance replacement cost for the 1% of construction it gives 18%. And for our calculation that we use, we got a total monthly cost for the 249,000 and 333. So to wrap up our project wastewater treatment from textile industry by coordination method, for the resident time distribution, we actually use resident time distribution in our project because it related with the industry, which is it is model using modified axial dispersion, and it also separate the impurities from the wastewater. And all industry which produce the water, which is produce the wastewater need to undergo wastewater treatment so that our earth stay green and clean, so with that we can preserve the nature. So I think that's all. Thank you.